The first case that we're going to have now is about using AI-powered tools in media monitoring. And we're going to hear from Swati Anand from Infomedia. Swati, are you here? You're there. Okay. Please welcome her. You've been spending the last 6 years on researching NLP and linguistics, so
yes.
Tell us about it.
Hi, I'm Swati Anand. I am a data scientist at Infomedia, and I've been in natural language processing AI for the last 6-7 years. Before Infomedia, I was in IBM, again, as a data scientist. I am fairly new to Denmark and Infomedia. Before, I was in India. Apart from that, I am a trained classical Indian dancer. I also do ballet, so I do a little bit of everything here and there. Beginning with the presentation, today we're going to be talking about the future of media monitoring and the future of media intelligence, insights for impact into the world of AI in media. That's what we're going to talk about. This is me. I already talked about myself. A little bit about Infomedia. What is it that we do in Infomedia? This is exactly what we do. We take a lot of media content from different sources, be it print media, be it web media, social media, all sorts of media. We apply a lot of machine learning models on them and create insights out of those. We are going to talk about a few of our projects to see how to create those insights. But this is essentially what is it with Infomedia. A sneak peek into what the presentation will be about. I have categorized it into 2 parts, which is what are those of our matured projects, which are in production yet, client-facing, directly, indirectly, and others are what's coming soon, what are our exciting POCs that we're currently working on. What's in production? Talking about the first project is sentiment analysis. It's one of our oldest projects. It's quite matured. It's with production already. It's about understanding the tone of the media coverage, because it would help devise strategy for a lot of PR firms. And this is why we do sentiment analysis. Because with a lot of news coverage comes the need to understand what is the tone behind the coverage. For example, if 90% of the media mentions are negative, is it even a good PR strategy? Like, is it even a good publicity? So this is what we create impact for, so that the customers, so that the companies, they understand if whatever that they're doing, do they have a good impact on the audience? It helps detecting risks. It helps empower the clients one way or the other. How do we do sentiment analysis? Don't worry, I'm not going to go into the technical details of our architectures, but I would like to mention that we work around with the BERT-based classification model, which has a 3-range scale, -1 being negative, 0 being neutral, and 1 being positive. This is exactly what we do. We understand what is the sentiment as it is in the picture. We have the article, we have the tone attached to it, and we derive the tone based on different parts of the news article, the heading, the sub-body, and the body of the article. The figures, these are just variables, so it can be tuned on what is it that you want to give more importance to. Is it the heading? Is it the body? But this is how we derive the sentiments. We have our models in all the Scandinavian languages and English, and other languages like German, French. All of these are in pipeline already. Challenges, but more like challenges, these are the current experiments that we're currently working on. First one being, I think it's a global challenge, What is a sentiment? What is positive to me could be negative to someone else. It is quite subjective. So if it is so confusing for a human, imagine how difficult it is to train a model to understand that kind of subjectivity bias. The other one is how we started with the project is that we have one model for each of the languages. And with our ambition, if we want to have a model for all the languages, it's going to be a hectic thing to do. And if we want to have one model which would perform excellently for all the languages, I think it's a huge investment, and it's a huge effort. And we're currently working on it, and let's see how it goes. This is our next project, which is topic modeling. It's one of my favorite projects for some reason. It is about deriving topics out of a collection of documents, whereas topics are just a set of words. And all these words combining together, they have like a shared theme to it. Why do we do topic modeling? It is to categorize the articles so that we can search them better. About the search, we're going to talk about this in detail a bit later also. But apart from search, I think this project has kind of broken the manual effort that was going on for like a few years now. So instead of manually finding the topic between each article, this project takes into account a lot of articles together and find the topics. And that is why we started with the project. Before talking about the formulations, I'm going to mention that I'm going to be a little technical for the next 3 slides. So it's fine if you miss out on the minute details here and there. Do not fret. It's going to be OK. Formulation for topic modeling, we work with a very famous statistical model called LDA. It's latent Dirichlet allocation. What happens in the model is we have 2 distributions. One distribution is over documents for topics, and the other distribution is the distribution of topics over words. Given these 2 distributions, we try to devise a probability that maximizes both the distributions. And basically, these distributions are based on frequency of the words, the co-occurrences of the words. It means that if 2 words, they tend to come together in one article, or they tend to come together a lot of times, the model thinks that they belong to the same cluster, they belong to the same topic. And this is the idea behind topic modeling. But after having assigned topics to each of the news articles, what if we realize that some of the words in the topic are not relevant to us, or some topics are completely not relevant to us? So this is what the refinement does. It lets you create your own topics. You can delete the words that you don't want. You can delete the topics you don't want. You can add new words. You can add new topics. So it basically empowers the customer to search with whatever topic that you desire. But of course, we need to be careful about the fact that these topics need to come from the data set. They need to be present in the data set in substantial quantity. Evaluation. And I would also like to mention about the fact that with evaluation, with refinement, there was not a lot of research in the community already. We had a hard time figuring out what can be used. So we ended up devising these algorithms ourselves. It's nothing super complicated, but it was something which was not available. So it's kind of novel to us. The evaluations are pretty simple. These are just the distance between the clusters. It's like if there are 2 topics, how well separated they are. If there's one topic, the words in that topic, how combined it is, how coherent they are with each other. So this is exactly what we came up with to evaluate our topic models. Challenges, again, not more like challenges, but like current experiment that we're working on. Like I mentioned, that the probability distribution for LDA, it works with co-occurrences and frequencies and not context. What is it, context? For example, with COVID, after a certain time, we all started talking about the variants of COVID, like Omicron, Delta. Nobody said COVID, the word. But for this model, it would differentiate between Delta and COVID. It would not think that both these exactly mean the same thing. So this is what the model needs to learn. This is what we need to work on. And the other thing is that if there are not enough documents about a certain topic, 2 topics tend to blend together, which is not what we want. We are already working on it. We are working on zero-shot classification and few-shot classification to get better architectures for topic modeling, but it's in pipeline. What's coming soon? These are exciting POCs we are currently working on. I'm going to talk about this one, AI-powered search. It's a huge name, but it's like a search engine that we're trying to create based on different categories that we are able to search the articles. Like I mentioned before, Infomedia has hundreds and thousands of articles coming in every day from different sources, and there is a need so that they can be structured properly, so that they can be searched properly, retrieved properly. I understand a database can do same job, but it's much more complicated than what we are trying to do right here. I'm going to talk about 3 different categories with which you can search. First one being topic modeling. I already talked about it. With different topic models saved, with fine-tuned topics that you, as a customer, want, then you just need new articles and infer on the previously saved models. So it's pretty helpful. The other one is related words, embedding search. Like I mentioned, it is context-based. It is not context-based. So we want something that can understand that 2 words, which are written in 2 completely different ways, might mean the same thing. This is our effort with embedding search to find the distance between the embeddings. This is our example. It is not there yet, but this is our first few experiments, and I think it's a win already, because when we search for healthcare system, it did prioritize an article saying living in greener areas is linked to better mental health and less drug use. So if you're considering that, if a model is considering mental health as a part of healthcare system, I think it's a win. So it is working great, and the idea behind it is that we generate embeddings for the articles, store them in the feature store, and then use some sort of indexation so we can retrieve and store using the indexes. That's the idea. Again, the challenges with that idea is, like I mentioned, we have hundreds and thousands of articles coming every day, so you need to update the indexes very frequently, add new articles, update the embeddings, update the feature store. It's a lot of effort to do updation regularly. And the other thing is, we work with Scandinavian languages, so it's Danish, Norwegian, Swedish. All these languages are resource scarce. So in the community, there are not many as great language models that we can get the embeddings from. So either we train a model of our own, which is, again, a bit of a struggle, or otherwise we settle for something which is not very accurate. So that's something we're working on right now. And the third one is grouped entities. It is finding entities in the article, what are the mentions, and how are the mentions related to each other. And for that, we have come up with our own knowledge graph. It's called Infomedia. We're quite proud of the name. So what happens is, it's a knowledge graph which started with KBpedia, and then we add all of our entities to it. There are knowledge bases and knowledge graphs present already, but we decided to come up of our own, because there's so many entities which are niche to Infomedia, which is not there on Wikidata or DBpedia. So that is why we have a knowledge graph of our own, and we try to enrich it every day with new entities, new relations. And then the maintenance is there, but once we have enriched the knowledge graph, it's like a cycle, because then we try to enrich the relation extraction pipeline. What it does is it tries to look for the mentions in the articles. It's called named entity recognition. And then once the entities are recognized in the article, it looks for disambiguation. What is disambiguation now? For example, if a word is mentioned, what is it exactly? How would you know? For example, the word mentioned, the entity mentioned is Jaguar. It could be Jaguar the animal, it could be Jaguar the car. What is it exactly? This is called disambiguation. That is the second step in the pipeline, and then it's entity linking using DBpedia. That's the entire pipeline for detecting the entities in the article, and then using the knowledge graph to find the relation between them. Again, the challenges with it is we have a lot of entities and a lot of relations, but since the whole process is automatized, there is a need to filter them and to validate them, and sometimes it has to be manual. So a lot of manual effort is there to maintain it and then to validate it. And like I mentioned, we have these 3 components which are projects in themselves. So they need to be combined together to make the whole AI-powered search engine in itself. And we are taking baby steps into it to bring everything together. I hope you like the glimpse into the future of media monitoring and media intelligence. And yeah, I'm done. If you have any questions, then I'm here. Thank you.
We have time for one question, if you have one. Yes, from the technical side of the room. Actually, we have a microphone, and please introduce yourself when you pose a question.
Hi, I'm David Caswell, and I have a slightly technical question, and it's about the whole field of natural language processing. So when you look at these models, summarization models, named entity extraction, sentiment analysis, again and again and again, you kind of look at these models, and then you can put the same task into a large language model, say GPT-4, and on the metrics, the large language models, the scaled large language models, do vastly better jobs than custom models from even 2 or 3 or 4 years ago. So how do you see the whole field of natural language processing changing when large language models with a fairly easy interface can take care of so many of these NLP tasks?
I think it's a very good question. I was thinking about addressing something like this, but I completely forgot during the presentation. So thank you so much for asking the question. In my opinion, I think it is too soon to talk about it. Because the language models, there's a huge hype around it, but they do not understand the little nuances that might be with working with the data set that we are right now. First of all, they're all research-based. So using them for commercial purposes, it's not possible right now. So we have to make do with all the small language models, if not the large ones. And second, if you try to train a language model of your own, then not every company, not every research lab has that kind of computational power, has not that kind of effort that they can put into training a language, because it takes days and months and TPU pods to train that kind of a model. So I think maybe in future, I think it can change the landscape, but right now it is too soon to talk about it.
Thank you. Thank you, Swati. Please give her a hand.